All right, welcome back.
Hi.
So, how do you all feel about what we're learning so far? Are we good to move on, or you want to review some of that, or what do you think?
I couldn't hear you. Could you say that again?
Oh, I said, how do you feel about the things that we've learned so far? You want to review some of that or move on? Like keep going?
I want to review a little more.
Okay. Can I say review a little more? What'd you say, Ibuka?
I'm good with them.
Okay, you're good. Okay, so we'll go back. We'll do a combination of those. So we'll do a little quick review on what we did last time, and then we didn't do the 6 through 10 of the problems from last time, so we'll do those, and that should be a little quick review. Okay, let me share my screen. Okay. All right, so we're here for lesson 6, and this one's on algebra. So again, from last time, algebra is using mathematical symbols and the rules for manipulating the symbols, or letters and symbols that represent numbers, and how you manipulate those. So when you start seeing X and Y and different letters in your equations, then that's usually algebra and the rules that you use. And so we're going to go through some more of those rules today. And this is going to be like the hardest lesson on algebra. Oh, I get a hand clap. Thank you. So yeah, this will be the hardest lesson on algebra. And then next week, we're going to do some more with graphing and some of these lines. And we're going to still be using algebra, but this will be the hardest thing that I'll give you for algebra. So a little bit from last time, we should have on our summary page of notes when we're talking about adding and subtracting negative numbers, or mainly subtracting negative numbers is when it gets a bit tricky. So if for the first one, -5 minus 2, if you start on the -5 and -2 means going to the left twice.
Can you get my page of notes?
Okay.
Page of notes.
Yep, so we have the -5 minus 2, start on the -5 and move 2 to the left, because it's the negative direction, and you end up on -7. Then if you get -5 minus a -2, that's kind of the same as doing -5 plus a +2. So if you start on -5 and now move to the right 2 times, then you end up on -3. And so we have that as with our variables in it, or our symbols, since we're doing more algebra stuff. And so that's when you start putting letters in. So if we have -a minus b, is the same as -a plus a -b, and then -a minus a -b is -a plus b. So you can end up behind you. Cool. I'm glad he's looking. So yes, this is good. Okay, and then we also talked about squares. When it's the same number times itself, you'll see 5 squared, which equals 5 raised to 2, or 5 to the 2nd power, which really just means 5 times 5. I think Shiloh's coming on. All right, so then you have, if you want to plug in the letters, for it, you'll have s squared equals s to the 2nd power, which equals s times s. Okay, got all that part. Okay, keep going. Then order of operations we did, parentheses, exponents, and then multiplication or division, whichever one happens left to right, whichever one you come across first, and then addition and subtraction left to right, whichever one you come across first. Hi, Shyla. And then multiplying negative numbers, where we had like signs and unlike signs is another way to look at it, but positive times a positive equals a positive, negative times a negative equals a positive. So any like signs it'll be positive, and then the ones at the bottom, negative times a positive is a negative, and positive times a negative is a negative. So things that are unlike signs always is negative. And so the same thing applies when you're dividing numbers. So if you did negative divided by a positive, you end up with a negative number. If you did a negative divided by a negative number, you get a positive number. Same rules for dividing. So that's our review. We did this last time where we just multiplied and divided using negative numbers. I think we did that part good. So I'm going to give you all time to do these. Okay. So I'll give you all a couple minutes to do these, and then we can go through them together. They're a little more difficult than last time, but just take your time and you all can get through them. Give some time. about a minute left. All right, y'all in a good place? No? Okay. You need more time or you just want to go ahead and go through them together? Shyla, what do you think?
Can we go through them together? Because I'm only on number 8.
Okay, yep, we'll do them together then. Good. All right, so I guess go through them. Shyla, since you were first, can you tell me the answers that you did get and the ones that you didn't understand yet? Oh, you're on mute. There you go.
For number 6, I got 32.
Okay.
And for number 7, I got negative 28.
28. Okay. And then you were still on number 8. Okay. Nana, you wanna tell me what you got?
I'm not sure where my page of notes went.
Mm-hmm.
I think my mom or dad threw it away because they didn't know.
Okay.
So I don't really remember all of the answers. Would have been easier for me if I saw my page of notes and I could work it out.
Yeah. Okay.
So I only know like number 6 for now. And my answer I got for it was 13.
Okay. And then the other ones you're not sure about, right?
Yeah.
Okay. Ibuka.
For number 8.
Let's go through all of them, 6 through 8. I mean 6 through 10. What answers did you get for all of them?
So for number 6, I got 13. For number 7, I got 49. For number 8, I got 10. For number 9, I got 72. And for number 10, I got 46.
Okay, good. That helps because yes, you got all of them correct. So good job, and then you can help Shyla and Kanina with how we do them. So Kanina, I know you said you got number 6. So how did you do that one?
Well, the same way I do it before. Like I do 2e to the power of 2, which means 2e times 3. So then 3 times 3 equals 9. So if I add 4 to it, then I get 13.
Right. Good. Did you understand that, Shyla? Yeah. So you do the squared part first, so which is the 3 times 3 part first, because that's the exponents in our order of operations. So Shyla, can you do number 7? How would you do that one? Unmute yourself.
I would do negative 7. Wait, no, I would do so like 2 to the power of 7.
Well, you were saying it right the first time, -7 to the power of 2. So what is that in multiplication form? So it's what times what?
7 times 7.
Right, the -7 times -7.
Yeah.
Yep. And so then what's -7 times -7?
Negative. Wait, no, it would be positive.
Good.
I'm not good with my sevens.
Okay, so how would you do it based on our multiplication table from before?
I would do 5 times 7.
Hmm. Which is what?
35.
Good. And then what?
And then 42.
Okay, that's 6 times 7.
So then it's 49.
Yep.
The answer is 49.
Yep, because we just did -7 times -7, which is positive 49, and then you just multiply by 1, which is just 49. Very good. Okay, so now it gets a little more tricky, but using that same thing that you just did, can you do number 8, Shyla, too? Because it's very similar. Just one more step.
Is it -5 times, wait, -5 to the power of 2?
Right, which is what?
So, which is 10.
Wait, be careful. So
25.
25, okay.
And
Yeah,
then times 2.
times 2, 25 times 2. That's what? I told you before, I think about it like money with quarters when it's 25. So 25 and 25, 2 quarters together. How much money is that?
For some reason I got 50.
Yeah, that's how much it is. Yeah.
Oh.
50. Okay. And then you do 50 divided by 5, which is what?
10.
Yeah, perfect. Okay, that's correct. So the answer to number 8 is 10. So first we did -5 times -5. You got positive 25. You multiply it by that 2 because that comes first, left to right. So you do 2 times 25, which is 50, divided by 5, which is 10. Very good. And then Abuka, you want to do number 9 and 10?
Extra quiet. For number 9, I got for number 9 I got 72, and this is how I did it. So I went back to PEMDAS, and I knew exponents came before multiplication, so I did that first. So -3 to the power of 2 would be -3 would be -3 times -3, and that's 9, because a negative times a negative equals a positive.
Okay.
And then I just had to do 8 times 9, which was 72.
Perfect. That's good. So Kanena, you got that written down?
What?
Are you writing that down?
The negative plus plus and like plus I mean negative plus a negative and like equal plus equal.
Well,
You mean the problems?
yeah, the problems, and then
Yeah, I've been writing some of them down.
and so Abuka just talked us through number 9, how to do that one. So make sure you're writing that down as we're walking through how to do that one. So for number 9 on your paper.
Number 9.
Yep, so you have 8 times -3 to the second power. So first we do the -3 times -3, which gives the positive 9. So we just have 8 times 9, which is 72. So yeah, so somebody else is going through how they got the answer. You write it down on your paper too. Okay, Booker, you want to do the last one? Is your dog still talking?
Nice quiet now. Okay, so for number 10, I got 46. So first what I did, I went back to the order of operations from DOS, and exponents came first, so I did that. 5 times 5, 5 to the power of 2 was 25, because 5 to the power of 2 was 5 times 5. Then I knew that multiplication came before addition, so I did that. 2 times 25 was 50, and then I added 3 and got 53. Then I had to do -7 plus 53, and when you're adding an and when you're adding a negative number to a positive number, then this explanation might not be right, but it's basically just flipping it over and doing subtraction instead. No, wait.
Yeah.
Yeah, you flip it over and do subtraction. So 53. So 53 minus 7 equals 46.
Good. Yeah, it took me a minute to figure out what 53 minus 7 was, but let me show you. Yeah, so those were all the answers. Make sure you write those down, but I'm going to show you what Luke was just talking about here. So for number 10, I think everybody understands how we got to the 53. So if we do, let's see here. So we had -7 plus 53. And then what he's saying is that's the same thing as 53 minus 7. Or another way to write it kind of is like the 53 plus -7, but it's all very similar. So that's how he was saying that he solved it. So that's how you got that one. So if you get the 53, I would give you partial credit for that. And then since we didn't really deal with numbers this big before, this one was kind of a more challenging one, -7 plus 53. You kind of rewrite it as 53 plus -7 or 53 minus 7. Okay, good there. Let's keep going. And so now this is like the hardest part about algebra is solving an equation. So you solve it for a variable usually, which is what we've been talking about for all of algebra. You're solving for a symbol. So what is X and what is Y? Oh yeah, Kosi's back. Okay. It's like, I thought I saw Kosi coming on here. Okay, so this one is inverse operations. That's the first thing you need when you're talking about solving an equation. So make sure you all write this down. So you have these operations like across the top, addition, subtraction, multiplication, and division. And the inverse of those operations, the inverse of adding is subtracting. So the inverse of subtracting is adding. And then the inverse of multiplication is division. Or the inverse of division is multiplication. And it's all similar. So make sure you all write that down. And then Kosi, can you read for us the equations that are written on that right side there?
Four plus 2 equals 6. 6 take away 4 equals 2. 3 times 4 equals 12. 12 divided by 3 equals 4.
Yep, very good. Thank you. Yep, and so those are like showing the inverse. And so basically all the same numbers are kind of in there, but it's inverse. So like how it says the inverse of addition is subtraction, the inverse of multiplication is division. So that's one thing you need to know when you're trying to solve an equation. And then pretty much the only, not the only other thing, but one of the other things you need to know is like now when we're trying to solve an equation, we reverse the order of operations. Do I have anything else on here? No, okay. You reverse the order of operations. So this is only for solving an equation. So let me actually add that. So yeah, you can put it in your notes there, but let me take this one. This is for solving an equation. For solving. So y'all can write this in your notes too. Okay, Shyla. We'll see you later. When did school start for you?
School started yesterday for me.
Oh, okay. Okay. Well, yes. Have fun in class. We'll see you later. And then when does school start for you all? Next week or the 31st?
For me and Kanana, September 1st.
Oh, okay. Yeah. Good. I know some schools it's August 31st. All right. So yeah, when we have problems that we want to simplify, we do that order of operations. But then when we're solving for an equation or solving for a variable in an equation, then you reverse the order. You do the addition and subtraction, multiplication and division, exponents, then the parentheses. So that's the second thing you need to know. And then there's one more thing you need to know, and then we'll practice some of this. So the third thing you need to know when solving equations is to group like terms together. So here's an example of one. This is the third step. So can you write down, step 3 is to group like terms. And it's the third thing you need to know. Well, it may not be step 3, but it's the third thing that you'll learn. Group like terms. And so, Abuka, have you done this before? Oh, I can't hear you.
I didn't finish writing down the last slide. Could you go back
Oh,
to
yeah, sure. Yeah, so it's the same as order of operations, except it's just the other way around. So it's like PEMDAS, but switched around when you're solving an equation.
Okay, I'm finished.
Good. Okay, so grouping like terms. Have you done something like this before?
No.
Oh, good. It's easy stuff, but it's good to know. So grouping like terms together. So in this problem here, the terms are basically numbers that have the x in them and numbers that don't have the x with them. So I will write these down. 3 plus 7 plus 5 plus minus 2. So I'm going to show you on my whiteboard how to do this one. Okay. So you all can see my whiteboard, right? My light screen there. Okay, so for that one, it's 3x plus 7 plus 5x minus 2. So everybody have that written down on your paper? You got it written down, good. Okay, so the different things are here is this one has the x with it. Those two have the x with it. And then these don't have the x. So you really just rewrite these together. It's probably the easiest way to do it at first. 3x plus 5x. And then you would have the other ones, 7 minus 2. And so what's 7 minus 2? Somebody can help me with that. Kosi, what's 7 minus 2? Kosi, what's the 7 minus 2?
7 minus 2 is 5.
Good. And then what's 3 plus 5?
3 plus 5 is 8.
Good. So that one, since it already had the x with it, you got to keep that x with it. So you end up with 8x plus 5. So we just combine the like terms, the terms that look alike. This is our answer. This is as simple as we can make it. 8x plus 5. Okay, so now I'm going to go back here. There you go. So when we talk about that problem, 3x plus 7 plus 5x minus 2, I'm going to show you all the steps here. I did the exact same thing, put the x's next to each other and the numbers next to each other. And then you end up with 8x plus 5. Kanina, you got that written down? Good. All right, so let's do another
I'm gonna
one.
make a little adjustments to it.
You did what?
I'm gonna make a little adjustments to it.
Okay. Yeah, so whichever way helps you learn it better or remember it better, so that when you go and look at it later, you'll know exactly what it is.
With your hands.
Okay, so we'll go on to this other one using everything we just learned with grouping like terms. Let's write this one down. And so I'll show you on my whiteboard again how to do it. Move this one over. And this one, we'll have 3x plus 7y plus 2x. Let's type this in. X minus 5y. And then same kind of thing here. The ones that have the x on them go together. And then the ones that have the y on them go together. So we write that to 3x plus 2x. And then you have So the plus 7y minus 5y. And then Kanina, what's 3 plus 2? So that 3x plus 2x. What's the 3 plus 2?
3 plus 2?
Mm-hmm.
3 plus 2 is 5.
Good. So then this goes to 5x. Then what's 7 minus 5?
7 minus 5 is 2.
Put 2y, since it had the y on there already. Very good. So that's what our answer would be for this one. 5x plus 2y. Okay. And then so I'm just going to show you back over here. I'm going to walk through it again so you can see it. 3x plus 7y plus 2x minus 5y. You put the x's together, 3x plus 2x, and you put the y's together, 7y minus 5y. You get the 5x and the 2y. So this is like, you've learned pretty much everything you need for algebra for the most part. But now, so we're going to do some practice problems and we'll spend some extra time working through them. I made them kind of tough, some of them. So everybody got this part? Okay, good. All right, so you solve the equation for x or y. So use what you learned on those other slides, the reverse order and the inverse operations to get the variable on one side. So we have a problem like this. So the reverse order of operations, instead of doing the multiplication first, you would do the subtraction first. Well, sorry, you do the addition first. And so you do the inverse of that. So let me write it on the whiteboard. 6x plus 3 equals, 6x plus 3 equals 27. I'm going to write it over here. 6x plus 3 equals 27. And so you do the addition first, but then you need to inverse that addition. So the inverse of addition is subtraction. So you do minus 3 from this side, and then you do minus 3 from this side. So you get 6x, and then you get plus 3 minus 3 is just 0. And then 27 minus 3 is 24.
I don't think I really understand this.
Okay. Yeah, so it's.
Neither do I.
Say it again?
Neither
Oh, you
do
do I. Okay, good. Okay, so this is kind of bringing it all together. So the main thing here is that we're trying to solve, let me erase this for now. We're trying to solve for what x is, this by itself. So we're going to end up with getting x equals something. That's what we're trying to solve for. X equals something. And we just don't know what. So we need to get x by itself. And so usually order of operations would be, please excuse my dear Aunt Sally. So this is really sits, and this is probably way more advanced for you guys than I anticipated, but 6x is the same thing as 6 times x. So if you've never really used these before, yeah, we can do some easier problems, but if you all understood what we've done up to this point, you're in a good place. And so let's just do it even simpler. Let's do x plus 3 equals 27. Let's just do that by itself for now. And so to figure out what x is by itself, you need to subtract this 3 from both sides. So you end up with x basically plus 0, 3 minus 3 equals 24. So x plus 0, anything plus 0 is just that number again. So you would end up with x equals 24, which is your answer. If somebody gave you this initial problem, x plus 3 equals 27, then the missing number is 24. And so a way to say this is like in your classes, you have, trying to think of a word problem that can do this. So you have, okay, there are X number of people in your class, X students, X number of students. This is the number of students. I'm gonna write all of that out. Number of students in your class. And then in your class, you also have 3 teachers' assistants, like between your teacher and their assistants. So it's 3 other people. And so in your class, there's 27 people total people. So now somebody would ask you, how many are students? If there's X number of students in your class and there's 3 teachers and assistants, how many people total are in there? So the total of 27 people, 3 are teachers. And so a quick way to kind of solve this would be you have 27 total people minus the 3 teachers. And so how many people are left? Anybody want to answer? Yeah, go ahead.
24 students.
Yeah, so then you have 24 students. And so that's kind of exactly the same thing as this problem that I gave you. So I'm going to erase this for now because that's getting way too complicated for you. So yeah, if you have X plus 3 teachers, so this is like the teacher number, teachers, and this is total people in your class. Then to figure out how many students there are, then you subtract the teachers from both sides. And so you get the number of students is 24. Does that make a little more sense? Or it's still very, very confusing? I know it's kind of a lot, but I told you this is going to be our hardest lesson. Abuka, where you?
I get it.
Okay, you get that? And Anna, did that help a little bit? Or it's still very confusing?
It's still a little bit confusing.
Okay, that's good. Yes, because you're going to the what, 3rd grade, so yeah, you learned a whole lot of things that I think you'll probably be learning up until you get to maybe 6th grade, 5th grade. So you've done a really good job so far. So even just still take some of these notes down, and as your mom said in the last one, like, you know, you'll pick up some things along the way, and then some things you'll just pick up a little later, but that's okay. So I gave you all some pretty difficult problems initially. Let me do, what's another way to do this? I'll give you all revised questions because these are too difficult for you all. Let me figure it out. Okay, so those 2 should be fine. I'll do that, that. Mm, I would do. Mm, modifying these, making a little easier. Yep, okay, that should do it. These answers are going to be wrong. Okay, let me give you all some time to do these. Hopefully they're a bit easier. They're still a little tricky, but that should be good. So for number 1 and 2, just simplify it like we did before. And you're not trying to solve for a letter. And then for 3, 4, and 5, for 3, you need to solve for x. So get x by itself. So use the opposite, the inverse operation. And so for 3, 4, and 5. And so for 5, you actually need to simplify and use that inverse operation. So I give you all some time and see what you can do with these. So if nothing else, try to write all of these down on your paper. Okay. I give you all some more time. I guess in the meantime, Kosi, can you explain to me how you do number 1? Yep, so number 1 is 3x plus 5x. How would you do that one? So,
Can you pay attention? Don't discuss that again with me because you're doing something.
do you know how to do number 1? Okay, so with the 3x plus 5x, it's you would just kind of add like those numbers. So 3 plus 5. So what's 3 plus 5?
8.
Good. So yep, so 3x plus 5x is 8x. And that's your answer.
Amazing.
So I know you haven't used x's before or anything like that in your at school yet, but this is really good for you to know now. So yeah, when you start having x's in there and you can add them together. Yep, so you did exactly right, 8x. And then Kanina, can you do number 2?
I'm still not sure I understand all of this. It's really confusing for me.
Yeah, I know it's a lot, but I know you can get this part, I think, for number 2. How do you think you would do it?
Me?
Yes.
Well, not really sure with all the X's and Y's between.
Mhm.
Like,
Yeah, so how many items in that problem have a Y with them? How many
2.
Y? Yep. So the 6Y and the 2Y. And so that sign that's in front of the 2Y is a minus sign. So if you did 6Y minus 2Y, what would that be? The 6 minus 2. Okay. The 6 minus 2. And then
Yeah.
what's 6 minus 2?
6 minus 2 is 4.
Yep, exactly. So I'm gonna put it actually right on here. So we end up getting 6Y minus 2Y. So I just grouped them both right next to each other, grouped them together. And so that's how you end up getting that answer that I have over there on the right. You did the 6Y minus the 2Y, which you said was 4Y. But then the X, there's only one thing that has the X in it. So it's just 4Y minus 4X. That's how it's simplified. Let's, all right. And so I will talk you through this easy one. Number 3. So for number 3, you have x plus 3 equals 27. So I'm going to put it over here. X plus 3 equals 27. X plus 3 equals 27. And so to get that 27, well, to get the x by itself, you got to put that 3 on the other side of the equal sign. So you got to subtract 3 and subtract 3. I think we did one just similar. It's exactly like this. So x basically equals 0, which is just x, equals 27 minus 3 is 4. So x equals 4. Sorry, 24. 24. 27 minus 3 is 24. Okay, so Kanina needs your help with these last 2. So how would you do number 4?
I only did number 1 and number 3. Got stuck.
Yeah, Luca, so you did number 1 and 3. Okay, so how would you do number 4? It's very similar, pretty similar to how you did number 3. Actually, I'm gonna change it a little bit. I'm gonna make this 2 plus y. Make it a little easier. So it's 2 plus y. We're trying to get the over there by itself.
Y be 35.
Yes. Yep, that's exactly right. Yep, because it's like 2 plus what number is 37? So yeah, 35. Again, in the fancy math way, you'd have 2 plus y 2 plus y equals, what was it? 37. Last one was 27. 37. And fancy math way, since this 2 is a positive 2, basically, so you would subtract the 2, and subtract the 2. And so 35. 35 equals 35. That's the longer way, but I think exactly how you get it was fine. Where you say what number, 3 plus what number is 37? So 35. Now, try to do number 5. Chukabuka? Can you try to do number 5?
Okay, so for number 5. Toba, quiet.
Toba, I'm talking, please.
Okay,
Do you need help on that one?
No.
Okay. So you can get the like terms together.
Yeah, I think I know the gist of what I'm doing.
You what?
Yeah, I think I kind of get it. I'll try it.
Yep. So first you gotta group the terms that look alike, and basically there's only one X in here, but then there's 2 numbers, a 7 and a 2. So you have that 7 minus 2 going on. I'm still gonna ask for your help, but I will, you can do it on the whiteboard together. So we have,
Actually, no, I don't have it.
I know it's a bit tricky. So this is like the hardest problem that we will do, and the last problem we will do today. And then next week we'll talk about like graphing things. So you have 7 plus x minus 2, and then the terms on this one that are similar to each other or like each other are these two. So we put those together, 7 minus 2, and then we leave our plus x equals 45. So then 7 minus 2, Kanina, 7 minus 2.
7 minus 2 is 5.
5 plus x equals 45. And then Abuka, how do we finish this up?
So you would just have to do 45 minus 5 and get 45 minus 5 and get 40.
Good. Equals 40. Perfect. That's exactly right. That's our, yes, this is very tricky, and it just gets harder or like just more complicated. But once you know all of these steps that we did today, you'll be in a really good place. We solved it. So we talked about, so today we did things on
The glass.
solving an equation.
The glass.
Solving an equation. There you go. And then, so we had our inverse operations. So instead of adding, you could subtract it. And instead of multiplying, you can divide it. when you're solving an equation. And then you reverse that order of operations. So the things that you did first, like that multiplication, you do after the addition. Group the like terms together. So things that have the x and then just the numbers by themselves. And then you isolate the variable. So you try to get that number on the side by itself. So for this one, the 6x plus 3 equals 27. So you subtract the 3 from both sides. You get 6x plus 0 equals 24. And then it gets more complicated, but we didn't talk about that today. And then same thing on this one, 7 minus 5y equals 42. You will subtract that 7 from both sides, and you end up with the negative 5y equals 35. And then you do more complicated things that we didn't talk about today. Good, so you all did these, and so let me finish filling out the answer. So x equals, for this one, x equals 24, y equals 35, and then x equals, let's see, we had x plus 5 equals 45. So you subtract the 5 on both sides and you got 40. So those are the answers to those. And so yeah, there's my info. I'll stop sharing. Any questions about what we did today? I know it's a lot, but I'm glad you all are seeing it first with me instead of in class and being very, very confused the first time you see it. But yeah, you all did really good. Yes, proud of you all. I will see you all Monday and we'll talk about like lines and graphing and a few other things on Monday for next week. But this was the hardest part of this week, and then it gets easier because it's just something different. So there's a lot of subjects in math, and some of them can get more and more and more and more complicated, and then some of them are just not as complicated, but it's easier for other people to get than others. So like graphing, I love graphing because I can see it compared to all of these numbers going around in letters. So we'll do that next time. So have a great weekend, and I will see you all Monday.